Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about feed recommendation. This topic is based on a tech blog titled WhataMix, Blendable Feed Construction, written by the Whatnot engineering team. You can find the blog link in this episode's description. Throughout this episode, we will explore this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Whatnot is the live stream shopping platform where sellers host auctions and buyers place bids in real time. The company was founded in Los Angeles and has grown rapidly and is one of the leading players in live commerce. It has over $3 billion in live stream sales in 2024. It is a vibrant and fast-paced marketplace where discovery and engagement are critical to user retention, and the feed experience plays a central role in making that happen. Every surface on Whatnot, whether it's the homepage, search result, category pages, relies on recommendation systems to surface the right content. A good feed helps buyers discover exciting items they didn't know they wanted, while giving sellers the visibility they need to grow their audience. In this context, feed quality directly impacts user engagement, seller success, and ultimately the company's bottom line. But as Whatnot scaled, the challenge of building and maintaining feeds became more complex. Different teams were tasked with developing different types of feeds: For You feeds, category-specific feeds, followed content feeds, and more. Each of these would serve different user intents. Some lean heavily on personalization, while others aim to encourage exploration. If without a shared and scalable foundation, teams could end up duplicating efforts, rebuilding similar logics in silo, and struggling to maintain consistent performance. This fragmented setup would slow innovation and made it harder to evolve recommendation system in a cohesive and efficient way. This is a clear problem that needed a scalable and a platform-level solution. Now that we've understood the business problem, let's dive into the technical side to see what is the team's solution. To address the growing complexity and duplication in feed construction, Whatnot developed a system called WhataMix. This is a flexible, unified platform for building recommendation feeds. At its core, WhataMix allows engineers to represent a recommender system as a directed acyclic graph, or DAG in short. Within this DAG, each node is a reusable modular unit that performs a specific function. These nodes can handle everything from candidate generation to filtering, scoring, and blending, essentially all the key steps in building a personalized and performant feed. This DAG-based design brings several valuable engineering benefits. First, it supports parallel execution. Any non-dependent nodes can run asynchronously, which speeds up feed computation. Second, it standardizes error handling. Developers can configure each node with a timeout and define whether a failure should stop the entire pipeline or simply be logged and skipped. The third one is that the system offers built-in observability. Nodes are instructed to track latencies, error rates, and execution traces. Some nodes even include wrappers for sampling inputs and outputs. This makes it easier to debug and monitor system behavior. This modular design is powerful for two reasons. It gives teams the flexibility for rapid prototype and launch new feed experience by reusing and recombining existing logic. And it improves maintainability as well. Because each node is isolated, it can be independently developed, tested, and optimized without risking side effects elsewhere in the system. Now, let's take a closer look at how this works in practice. Every WhataMix DAG starts with a source node, which fetches the initial batch of content candidates. Depending on the feed's purpose, this could be live auctions, trending items, or recently viewed listings. The candidates then pass through a series of transformation nodes. For instance, a filter node might remove items that the user had already seen, while a scoring node might assign relevance based on user behavior, preference, or previous interactions. After filtering and scoring, the pipeline reaches what's often referred to as the business logic stage. This is where additional adjustments can be applied. For example, the system might enforce category diversity, insert some static content at fixed positions, or blend scores from multiple subfeeds. These blending strategies can help the system to strike a balance between novelty and relevance, which enables the team the capability to create feeds with different types of context and mix-match them in a singular feed. Of course, the effectiveness of this design depends on how well the individual nodes are crafted to be truly reusable across different feeds. And that's not always straightforward. Some functionality is relatively easy to abstract, but other components might require more careful design decisions. A node needs to be general enough to support a wide range of use cases, yet specific enough that developers don't have to constantly adjust it for each new configuration. To maintain this dedicated balance, the team established a core group of maintainers for the WhataMix platform. These maintainers guide the evolution of the DAG framework, review proposed changes, and help establish platform-wide best practices. They also work closely with engineering teams to identify opportunities for creating reusable nodes, to ensure that new development efforts contribute back to the shared platform, rather than becoming isolated one-off solutions. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we looked at how Whatnot approached the challenge of scaling feed recommendation systems across a fast-growing platform. We explored WhataMix, which is a DAG-based framework that empowers the team to build, test, and develop feed logic with reusable and modular components. It's a great example of how thoughtful system design can drive both speed and quality in machine learning infrastructure. If you like the content of this episode, please subscribe to the channel, give me a 5-star review, and leave a comment. Your feedback is very appreciated, and I'll see you next week.